49. For purchasing a batch reactor, could be any equipment, three alternatives P, Q, and R have emerged as summarized in the table. So they have given the installed cost, equipment life, and the maintenance cost. For a compound rate of interest 10%, so we know I is equal to 0.1. Choose the correct option that arranges the alternatives in order from the least expensive to the most expensive. See, this comparing the project cost, there are several methods. One of the very popular methods is, of course, annualized cost, which is given by, this is the maintenance cost, which is this one right here. And this, of course, is a function of the interest rate, and TC is the capital cost. Okay. What we have here, so this method is also known as equivalent annual cost, so ESC method, and this is given in G. Towler and RSC nut. This is the page number. So that's the way, this is one of the ways you can compare the project alternatives. So I'm showing the calculation for one particular one. Let's say for project P. Here, this is 4, this is the AMC, this is 4 here, and this, of course, this is the value of I, and this TC is equal to installed cost. That's the total cost here. Okay, and if we do the calculation, it becomes 10.03 lakhs. So I've given here 10.03 lakhs. The other calculations are, of course, shown in the website. So as you can see, if you go from the least expensive to the most expensive, it would be R, Q, P. So C is the correct option. Now, what is the basic behind this annualized cost? What it does, it actually takes the project cost and the maintenance cost and divides equally for each year along the project cost. So this is for let's say 1, and this is 2, and 3. It's right here, so this is 0, 1, 2, and 3. So for each year, what will be the value? So that's 10.03 lakhs. So that's taking into account all the values here, the maintenance cost and the project cost for a total year of project life. That means 3 years. So that is the basic idea behind this ESC method. There is another method which is given, of course, in Peters and Timmerhouse, which is capitalized cost method. In this method, you see this CV is the installed cost here, so which is this one right here, and CR is the replacement cost at the end of the service life. So let's say this is my here, so this is my 0, this is 1, this is 2, and the third year. It assumes that at the end of the third year, we'll have that enough money to pay again 15 lakhs to buy a new one. So this is given as CI minus PS. So this is assuming that the cost after 3 years of this equipment, let's say batch reactor, will be the same as it has been purchased 3 years ago in this particular case. So which would be 15 lakhs, right? So and this CS is the salvage value. So since salvage value is not given here, so we are assuming this salvage value is equal to 0, and we are assuming that CI is equal to CV. That means after 3 years, the cost of the batch reactor will be the same as it had been 3 years before. So what we have here, so this is going to be 15, that's the installed cost. So CR again is equal to CV, so which is 15 right here after 3 years, and this value I is equal to, of course, 0.1, and CM, of course, is equal to 4. So that's the one, and that way we get around 100.31 lakhs. So that's for Q. Similarly, the calculations for Q and R are shown in the website. Okay, so again, if you take this method, CC method, we can see that it goes along this direction, RQP. So we get the same conclusion that that option C is the correct one. Just one quick thing I want to say that CC value what you get is equal to TSC value which we have calculated before divided by I only. So I just want to show you, let's for P this is 100.31 and the TSC value was 10.03. So CC value will be equal to 10.03 divided by I is equal to 0.1 which is equal to 100.3. So the same values for Q and R. So there are two methods. Summary, there are two methods. We can do it by the ESC method or we can do it by the CC method. So either way, we come to the same conclusion that C is the correct option.